All right, let's get right into it. We're always hearing about how AI is getting smarter, right? But how does that actually happen under the hood? Well, today we're going to look at a really huge shift in how we build AI. We're moving from simple API calls to a much more powerful idea called MCP reasoning. And this is the secret sauce for upgrading LLMs from just being basic apps into becoming true thinking agents. So this is really the central question for today. You've all used a chatbot, the kind that can answer a simple question or do one little task. But how do we get from that to something that can genuinely think, plan, and act on its own? The answer, it turns out, is all about how we let it talk to the digital world around it. So yeah, section 1, from apps to agents. This is the journey we're talking about. And the big leap here isn't just about making the models bigger or throwing more data at them. Nope. It requires us to completely rethink how these models connect to, and more importantly, understand the tools we give them. To get that, we gotta first look at how things usually work right. Which brings us right here to the API method. Now, if you've done any kind of work with software or AI, you have definitely heard of APIs. It's pretty much the standard for how most LLMs interact with anything outside of themselves. And when we talk about an LLM using an API, it's really all about one thing: direct execution. Just doing what it's told. Think of an API like a menu on a vending machine. Seriously, it tells the model exactly what it can order. Get the weather for London, press A5. Book a flight to Tokyo, press C2. It has specific inputs and a totally predictable output. The model can push the buttons, but here's the key. It has absolutely zero understanding of how the machine works on the inside or what other ingredients might be available. It just knows the menu. So the whole process is super rigid. It's a straight line. The model gets a list of tools that are already defined for it. It picks one, it calls that specific function, and it gets back exactly what it was told it would get back. It's a simple command and control relationship. Follow the instruction, get the result. That's it.
And look, for simple, predictable tasks, this is totally fine. It works great for fixed workflows where you know exactly what needs to happen. But, and this is a huge but, here's the critical limitation: the logic for why a tool should be used, or maybe how different tools could be combined in a creative way, all of that thinking stays completely outside the model's brain. The LLM isn't reasoning. It's just running a script that a person wrote for it.
And that right there is the wall. That's the wall we hit with APIs. If what we want is an AI that can solve really complex, multi-step problems all by itself, it needs to do more than just follow a recipe. It has to be able to write its own recipe. It needs to be able to reason. So, how do we get over that wall? Well, that brings us to the next big idea, the MCP method. This is the evolution. It stands for Model Context Protocol, and it's all about shifting our thinking from simple execution to genuine, what we call capability reasoning. Okay, so if the API was our vending machine menu, MCP is like giving the AI the keys to a master chef's pantry. It doesn't just list out a few pre-made meals. Oh no, it describes all the ingredients, the tools, and it explains what they're capable of. And that little bit of context, well, it changes everything. So instead of just saying, here's the weather function, MCP explains that there's a weather tool that is capable of fetching current conditions, getting forecasts, even pulling historical data. And it suggests it should be used for, any weather-related questions. This rich context is what lets the model actually understand its own toolkit. And this is where you really start to see the magic. This approach is built for the kind of complexity we see in real AI agents. It makes multi-step reasoning possible, where the model can chain different tools together in new ways to solve a problem it's never seen before. The connections are way less brittle because the model understands the capability, not just one single rigid function call that could break. All right, let's put these two side by side because this is where it's all gonna click. If you've been multitasking, now's the time to tune back in because this is the core takeaway of this whole explainer: execution versus reasoning. So on the left, you've got the API world. It exposes specific functions. It's best for these fixed, predictable workflows. And the key thing, all the decision-making, the brains, is external to the model. But then you look over on the right at MCP. It exposes full capabilities. It's built for dynamic, changing environments. And crucially, the reasoning happens inside the model itself. The intelligence literally moves from the code around the model into the model. Let's just boil it all down to one single line. If you walk away with one thing, let it be this: API equals function execution. MCP equals capability reasoning. It sounds simple, But that little distinction, it represents a massive paradigm shift in how we think about and build AI.
Which leads us to our final and maybe most important section. Why does any of this actually matter? I mean, is this just some technical detail for developers? Not at all. It comes down to two really important things: scalability and true autonomy.
I mean, this chart says it all, doesn't it? If you try to build a complex, adaptable AI agent using that old, rigid API-based approach, you just can't scale it. It's a nightmare. You have to manually code every single new interaction. But with MCP, you give the agent the ability to understand its own tools. That lets it scale and adapt to new challenges all on its own. Ultimately, that's what we're talking about here. An API-based system is always going to be limited by the scripts that we humans write for it. But an MCP-based agent, one that's equipped with reasoning, it can look at a new situation, understand the tools it has available, and come up with its own plan. It can write its own script.
And so that's the question I want to leave you with. Once we start building agents that don't just execute our commands, but actually understand their own capabilities, what happens then? What new frontier of problem solving does that unlock? What kind of challenges in science, in business, in our everyday lives are they going to tackle first? The possibilities, well, they're really just beginning to unfold.